Hi guys, Sajjad Hussain again with a new video. In this video I shall use the same old model which I have discussed before, but at this time I shall use the advanced concrete design module of STAAD Pro. Before I did not use that, but this time I am going to explain how the advanced concrete design of STAAD can be used, and we will see very surprising results, I can say. These results will be really very good, and hopefully you will be with me till the end of this presentation so that you will enjoy this video a lot. So let's start. This model, as I explained to you, I took from this reference, that is the seismic and wind design of concrete buildings, and the geometry was like this. There are 7 bays in east-west direction. This indicates the north-south direction. So in east-west there are 7 bays. In north-south there are 3 bays. The distances are 26 in east-west direction, and in north-south 22. And shear wall is here and here. And this building is 12-story building. This building, I supposed to design this as a seismic design category C building. And for this seismic design category C building, it is supposed to be located in New York with zip code 10013. The parameters are given over here. The seismic design data is SS is equals to 0.424 G, S1 is equals to 0.094 G, site class is D, and occupancy category is 1. Wind data is 110 mile per hour, exposure category B, and occupancy is 1. The parameters are here, the members dimensions are here. Slab 8 inch, beam 22 by 22 inch, interior columns are 26 by 26 inch, edge columns are 24 by 24 inch, and wall thickness is 12 inch. So this structure has been modeled accordingly. To have a clear picture, what I did, I prepared a calculation report, and I might have shown you this report before, that in this example I will be following ACI 31811 and ASC 705. Those parameters which were given over there is included over here, and I calculated the earthquake coefficient and wind load on this structure. And at the same time, basic loads as specified in this example has been calculated over here, and these loads are already applied. The important thing is that in seismic condition, in north and south direction, we have 2 different coefficients, and STAAD gives us exactly the same. So this was also established. Of course, this was the responsive spectra used. This building was assigned a seismic category C. These were the parameters from ASC 705 table 12-2-1, and the condition taken was E8. And based on that, the value of CS comes out to be 0.032 in north-south direction. And similarly, we can calculate the east-west direction, where CS comes out to be 0.024, as it has already been calculated in the reference book. So I included all these parameters here. I defined the loads, I defined the wind loads, I defined the seismic loads, and then loads were defined, and the load combination from load combination number 8 to 31, 30, the load combination is defined for concrete design. That means they are ultimate load combinations. And from 31 onward up to 59, the load combinations are defined for crack control and for sizing of the foundation. So both the load combinations are defined, that is the ultimate and allowable stress design load combination as per ASC 705. So I run this model and we get the results. When I use the design module of inbuilt design modules of STAAD, the results were not very promising. So I'm going to use advanced concrete design module. Now I'm going to tell you how to use this advanced concrete design module. So when we click on advanced concrete design module, we get this page. We have to define a client. Let's say the client is test. I'm going to use ACI 318M 2011 and I'm going to design the beams. The beams which are going to be selected are listed over here. These are the floor levels. So we will select all the beams starting from floor level 1 to 12. And we will create a new project. It will take little time. So here are the beams. Various beams are merged together. For example, this beam G1, this is the beam G1. All these beams which were individual beams over here, they are merged together and one beam is assigned as G1, then G2, then G3, G4 and so on. These are the levels already defined. So we will get a very nice geometry also, which is a very good drawing also. Now we are going to define various settings. For example, general and reinforcement setting. We are going to use a C30 concrete. Steel grade is 420. These covers are on default, so no need to change, all default. Here on the left hand side, we will ignore torsion, can be. It's no need to have a ductile design at this stage. So yeah, here we are going to check the width of the crack also, and as per ACI 224R-01, the permissible crack width is 0.3 for our conditions. So I am going to use 0.3 millimeter. That's fine. Rebar curtailment, let it be for the default values. Detailed drawing, well, let it be the default values. Preferred bar spacing, I'm not going to have any preferred bar spacing. Basic loads, yeah, here it is important. We have to define the basic loads. This was seismic load in X. This was seismic load in, sorry, not Y, in Z. This was the dead load. This was live load. This was reducible live load. That was the roof load. And this load was wind in X. This load was wind in Z direction. Select all by clicking on shift key. We have to select all. Okay, now we have to define the load combinations. So what we will do, either we can add from template or we will add from analysis. We have already defined in analysis, so no need to define it again. And let's see, for the design, our load cases were up to load case number 30. So this should be clicked. From 31 onward was for crack control. No need to have any click over here. No need to click over here. Right. And for crack width, let us add from analysis. Of course, we will start from 31 onward. All these loads were allowable stress design loads. So we will click all these loads till end. Okay, so all the settings are defined. Let us design, auto design. Okay, fine. It will take some time, please bear with me. So in fact, STAAD has developed a very nice module to design concrete structures. This is realistic design, I can say, and it gives very realistic values. Of course, because this is a huge model, lot of beams are there, so lot of iterations are needed. It will take some time. Meanwhile, we can see what was the design in the reference book. So let's see over here. The beam was designed between grid C4 and C5 at second floor level, and the bars are provide 2 number 8 bars or 2 number 7 bars for minimum. So better we can provide 2 number 8 bars. We will see how many bars we are getting from STAAD, rather, or 3 number 7 bars. This is the recommended final one. So we will use, or we will check whether how many bars are used or calculated by STAAD. We will see. Similarly, for shear design, it has been calculated something like use 12 number 3 stirrups at each end of the beam spaced at 4 inches on center, where the first stirrup located 2 inch from the face of the support. For the remainder of the beam, the stirrup should be something around 9 inch. Number 3 stirrups at 9 inch. So let's see. Still we have to wait for some time. Yeah, now it is already designed. It looks a lot of bars are provided over here. Okay, we will see. Now let's see if there is any failure. None of the beams have failed. This is okay. Then we can develop the schedule. Let the type 1 schedule, which is a nice schedule, has been developed by STAAD. You can see the beam schedule, levels, all levels are given, beam numbers are tabulated, dimensions are given, bottom reinforcement is given, top reinforcement is also given, left side the stirrups are also given. Left, mid and right the stirrups are given. It looks that these reinforcement are on little bit higher side, but anyway this is safe, no problem. Then we can see the elevation and section. Let it be all sections. Mark the anchorage, cross section of the beam, cross section of the beam, cross section, cross beam, and show the section mark also. Okay. Very informative and very impressive results are there, very presentable. I can say directly you can take these results and develop your final construction drawings. This is the beam elevation. Look how much details are provided. The anchorage is provided, and the curtailment, every detail is provided. Very good. So whatever required information is needed, it is already provided with lot of sections already cut. Let's see the sections over here. These sections are here. Look how nice the sections are. These are the beam dimensions, beam section, top bars, bottom bars. Of course, these are in MKS system, so these bars are in millimeter size, not in inch size, so no need to be confused with this number. Actually this is 16 millimeter, 16 millimeter dia bar at the top, and here 13 millimeter dia 5 bar at bottom. We can control this by specifying minimum bars over there, but since this is just for education purposes, so I wanted to show you how nicely the beams are designed and the drawings are prepared. We can use directly these beam elevations, sections, everything in our drawings, and very nice drawings, error-free drawings can be prepared. After that, project settings. Well, okay, these are the project settings. Design summary. It will take little time. Let us wait. It can provide also detailed design calculation, but it will take some time to develop the design calculation for that many. Okay, So here are the beam design summary. You can see they are all tabulated. Let us print only couple of design calculations. Say for example, instead of all beam, I'm going to select only one beam as a sample. Otherwise we can select all beams and very nice calculation result, report can be prepared. Here is the beam design calculation only for one beam as a sample. All details are provided over here. You can check manually. And I check these calculations are okay. Crack width check. Yes, we can check. It's going to take a little time. Here is the crack width check. No problem, all the crack widths are within the limits, less than 0.3 millimeter. So our design is safe. Maximum I can see 0.2159. And bill of quantities. Okay, bill of quantities summary, reinforcement, level and rebar wise. I'm not going to input any value over here. Currency should be dollar. Okay. So bill of quantities are also ready for quick reference. So now we have seen that very detailed calculations and drawings are ready. We just need to take these elevations, drawings, and we can incorporate in our model. So here is the plan, and for output, all these outputs are there, and drawing format, you can just export this drawing into MicroStation, or you can convert into DXF and add in your drawing in AutoCAD. So this is very, very impressive. Let us save the file. Save. Now similarly, we can design the columns. Let's say new. Client is test. Design code is 318 SEI 318 2011 metric edition, and we want to use. Now let us start column design. So I have selected column and wall as per ACI 318M 2011. Let us create the project. It will take some time. Okay, so here are the columns. These are the columns, column sizes, level data, concrete. Let us select C30. let's just select C30 for all. Okay, fine. Let us define the basic loads. This is seismic X, seismic Z, dead load, live load, reducible live load, wind in X and wind in Z. So select all, done. Now we will select the load combinations from analysis. They should also be highlighted. No. I took it out. Okay, fine. Let us have design settings. I don't want to. Okay, let's edit the effective length factor. These values are too high. All these should be 1. Okay, I think rest of the options should be left to the default. Let us start the design. It will take some time. Design is done. Let's check any failure. No failed column. So we can save this file as DXF file. I can say these are the column locations. Columns location. We can save this project. Now report, text schedule, so here is the text schedule. Generated. Let's see. Very detailed text schedule. All the columns, their dimension, bars, links, everything is given. Let us save. We can say this column schedule. Let's see the detailed drawing of all the columns. Because of huge data, it takes little time. Have patience. Just wait for a couple of minutes. Still is going to take some more time. Still it needs some more time. Because a lot of column data is there, so it has to generate all these drawings in drawing format, so it's going to take some more time. Have to wait. I should have selected only one column as a sample. I thought it will take less time, but unfortunately it's taking very long time. I have to wait. Still there's something wrong. See, it's not responding. Oh, thanks God, it is done. Here is the detailed drawing. That's why it was taking that much time. My God. Oh. So column sections are there, stirrups details are there, every detail is there. Oh my God. Really I am impressed with the result. Oh my God. Let us save the DXF file. So these are column details. Now let's see design summary. Thanks God. Here is the design summary. Let us print this. This is column design summary. Calculation. Okay, I will check only one. I will not check all. It will take a lot of time. Okay, just to save the time, I'm going to check only one. Column design. Thanks God. Here it is. One can see all the detailed calculation over there. Let us print this also in PDF. Column design calculation. Then bill of quantities. Okay. It should be in dollar. Yeah, okay. Let's print this one also. PDF. Column BOQ. This is column layout. So you can see how detailed information we can print, and we can directly generate the IFC drawings. Lot of information can be transferred seamlessly. That's the beauty of this advanced RCDC, that the information can be transferred seamlessly without any error. Save. Yes. Now let us design these slabs. $318,2000. Let's design the slab. I'll select only one slab for the time being. It can be selected only one slab can be selected, so let's select this one. As usual, so we have to provide a load. So we have to provide the superimposed dead load and live load. The superimposed dead load was 50 pound per square foot, which is equivalent to 2.349, which is 2.349 kilonewton per square meter. And the live load was 30 pound per square foot, that means 1.436. So let's copy. The slab was 8 inches, that means 200. What else is there? Okay. Let's see the design parameters. Okay, no bent up bars, rebars, two slabs simply supported, continuous, okay. Concrete is C30, cover, okay. Detailing option should be, let's select spacing, preferred spacing is 150, that's correct. Okay. Now let's design. Oh, so slabs are also designed. Number 10 bar at 300 center to center, that means it looks minimum steel is required. Reports. Let's save the file. Reports. Yeah. Okay, good. Let us save the DXF file. This slab table or slab schedule. Directly you can insert this into detailed drawing. General arrangement plan. Wow. Let us save the DXF file. Slab arrangement. Wow. So nice. Wow. Very impressive. Really very impressive. In plan detailing. Oh, very good. Let us save this also as slab detailing. Let's see. slab section. Not interested that much. Staircase is not there. Project setting. Okay, we can print. Slab settings. What else? Design summary. Good. Let's save this as slab design summary. Then design calculation. I can add here. Okay, so this is the slab design calculation. One can check. Let us print PDF. Slab design calcs. BOQ. Okay, it should be dollar. So we can save, print this as slab BOQ. Now bar bending schedule, let us see. Okay, bar bending schedule. Okay, so detailed bar bending schedule is generated. Oh my God, really it's impressive. Really it's impressive. Let us save as slab bar bending schedule. Oh my God, really. Such huge detail is generated. Now we can design all these slabs and we can develop similar results, and it's going to save a lot of time during generation of the construction drawings. My God, really very impressive. Now we can design foundation also. Yes, I want to save. Let's see the foundations. The same way, footing. Okay. Wow. Net bearing capacity 200 kilonewton per square meter, that is correct. C30. Okay, Soil density, depth of the foundation is 4 meter. Okay. Water table, it's not 1 meter, rather water table is maybe 10 meters. Permissible loss of contact 50%. Okay. Load cases, earthquake X, earthquake Z, dead, live, reducible life. This is wind X, wind Z. Let's select all. Okay, so for design, from analysis, it should be up to here, up to 30. No, 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 and no. No. And for sizing, from analysis, no, 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 no. From 31 onward, yes. Buoyancy, okay. It's not there, but anyway, let's check. For sliding, no. Overturning, no, 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 no. Yes, yes. Okay. Fine. Detailing, etc. Let it be default. Let's design. Oh, only one overlapping is there. We can ignore that one, no problem. For the time being, let us save this as foundation plan. Save this project. Nice. We can save this also. Foundation schedule. Oh my God, really, I'm very much impressed by this. Details. Let's select all. Detailed drawing for plan, section length and this. Okay, let's take a little bit more time, but not an issue. It's really very impressive that such details are generated, and the good thing is that all these details, that information will flawlessly transfer from one module to another module, so there is no mismatch. That's a big issue. If you do not transfer your information flawlessly, then there are even chances that at some location you miss something and there will be a mismatch in your design. That is really great. It will take a little time, no problem. Meanwhile, I can do one thing. I'll try to see the drawings over here. I'll import the DXF file. Let me open a DXF file. For example, foundation plan, or let's see, yeah, foundation column layout. Okay. Oh my god. What a nice drawing. My god. Absolutely perfect drawing is there. Column numbers, marvelous, really it's very impressive. I can open one more. Let's say foundation plan. Let's open this one. Yeah, only here there is a mismatch, or that they are overlapping, but anyway it's not an issue, but it can be checked. Really, that's great. So now the detailed drawing has been generated. My god, oh, really very good drawing. Let us save the DXF file. Foundation details. Let's save this file. What else we can generate? Design summary. Oh yes, it can be printed in PDF. Foundation design, foundation design summary. What else I can print? Design calculation. Say for example only one foundation. Here is the calculation for only one foundation. Okay. Foundation calc. Pressure check, say for example only one. Load cases. So these are the governing factors. Okay. Foundation pressure. So I can save all these files. BOQ. Okay. It's very impressive. Let's save this as foundation BOQ. Then the bar bending schedule. Let us generate the bar bending schedule for all. Yep. Okay. Maybe it will take little time, but it's worth to see the bar bending schedule. Oh my God. It's worth to save. Foundation bar bending schedule. Let's open these files in AutoCAD. Let's close this one. No, I don't want to do anything. Save changes. No. Let's open this foundation bar bending schedule. Oh, big data. Taking little time. Oh. Let's see. So here is the plan. Here is the section, and here is the bar bending schedule. Very detailed information, and now easily we can generate the drawings, IFC drawings, without any problem. Flawless drawing can be generated. Thank you very much. Hopefully it's quite informative for you. Bye.